Hello everyone, this is the Dr. Caleb Chen and in the statistics series, and we are introducing you to two concepts under the topic of numerical measures or numerical analysis as part of describing data. So we're still talking about how to describe data effectively as we summarize them, and one thing that we want to learn about a data distribution is how much is the spread. So both of these basically they are spread measures, SPREAD spread, and sample variance and standard deviation. They are basically cousins of one another. We have other measures such as finding the range, which is nothing but the maximum value minus the minimum value, that is the range. But this concept, standard deviation, is going to be very powerful, and the way to calculate a standard deviation is we use this equation. S for sample standard deviation is equal to the square root of this operation. In the numerator we have summing, okay, of the following expression. It's going to be the x minus x bar squared. So we're taking each of the x value out of a data distribution, take it and subtract the average from it and square that and divide it by n minus 1. This is the equation, and we're going to use a very simple example to illustrate that. And the best way to do that is to look at like my example would be the hourly wages of a sample of part-time employees at Home Depot, and the values x, and x is the hourly wages of the employees, and x is equal to the $12, $10, actually 20, I'm sorry, 12, 20, 16, 18, and then 19. What we want to do is to find the standard deviation. The standard deviation is a measure of spread that tells us how far is each value on average from the center. So we have to find the center first. The average is going to be the 17, because the total of these 5 values is 85. So the 85 divided by 5 is going to give us 17, and the $17. Now to calculate the standard deviation, we're going to take each of these values. So we're going to arrange this into the following. So with the x value, we have the x minus x bar column. So we'll set it up. So 12, 20, 16, 18, and 19. So 12 minus 17, 20 minus 17, 16 minus 17, 18 minus 17, and 19 minus 17. And that would give us the following. This is minus 5. This is 3. This is minus 1, 1, and 2. Well, what we need to do is to take the square of each of this expression. So x minus x bar squared is going to be the minus 5 times minus 5 is going to be 25. 3 times 3 is 9. Minus 1 times minus 1 is going to be 1. And 1 and 2 times 2 is equal to 4. And we are going to, according to this equation, we are going to sum everything together. So we have 25 plus 10, that's 35. 35 plus 5, that is 40. So right here is 40, and n is the number of values. So there are 5 employees hourly wages. So 5 minus 1 is equal to 4. So basically it's the square root of 10, which it turns out to be the, well, if we do some quick calculation, So what is the square root of 10? 10 square root, I have 3.16. If we round to the second decimal place, $3.16 is the standard deviation, which again is a spread measure that tells us what on average each employee's hourly wage is $3.16 from $17, which is the mean. There are employees such as what that this employee, let's use another example, such as this employee's hourly wage, which is what the $5 from 17, which is more than the one standard deviation. There are also other employees what their hourly wage, the average spread is smaller than 3.16, but we call it one standard deviation.